Learn it all, especially in a couple days. We've tried to group our products into series. So with the rubber product, the first two numbers indicate the series name. So 7430 is in the 74 series, 7580 is in the 75 series. With the rubber product, the last two numbers in the product name indicate the approximate hardness on the Shore A scale. So the higher the number, the harder it is. The lower the number, the softer it is. So 7430 is in the 74 series, and it's a 30 Shore A product, which is about as hard as the palm of your hand. 7580 is in the 75 series. It's an 80 Shore A, and it's very, very hard. The scale ranges from 0 to 100. If you get that much down, then when I throw out a product name 8190, you may not know anything about 8190, but you know it's in the 81 series, and you know it's a 90 Shore A hardness. If I say 7420, it's in the 74 series, it's a 20 Shore A. So at least you have some sort of knowledge. If we throw something out at you, you're not totally lost. If you can get that much down, then it'll make your life a lot easier over the next couple of days when we talk about different products. We're going to talk about the rubber materials first. We have polygel series. Polygel means that it chemically thickens. So when we mix A and B together, instead of getting a liquid form of rubber, it will gel. And depending on the product, it'll gel to a relatively thin mixture that will cling only about a 1/16 of an inch on a vertical to a product that will thicken and be like mayonnaise or grease. So if you want to do brush-on molds and you don't want to have to add any third components to make something thicker, then the polygel product would work. We also have scramble versions, so if you're doing very large objects, there's machinery that will pump and dispense the liquid rubber, gets mixed in a static mixture, which we'll talk about later, and you can just spray it on the wall and it stays where you spray it. So that's polygel, self-thickening polyurethane rubber. Then we have the 74 series, 75 series, 77 series, 81 series. We're starting around on numbers, we keep having more and more series. But all of these polyurethane rubbers are good for casting things like waxes and plaster, concrete, polyurethane and epoxy casting resins, as long as you use a release agent. The only thing they're really not suitable for is polyester resin. Polyester resin is the fiberglass resin they make car bodies and boats out of. That type of resin has styrene in it. That styrene solvent will get into the rubbers and cause rubbers to swell. Relatively quickly, within 3 or 4 casts, you start to see that swelling. So, if you need 1 or 2 pieces in polyester, urethanes are fine. Otherwise, you're going to have to go to silicone. Polyurethane rubbers are very adhesive. They want to stick to everything. So, if your model is made out of anything but maybe wax, the polyurethane rubber is going to stick to it. So, you need to apply release agent. So if your model is non-porous, so if it's glass or metal or plastic, you simply apply release agent, apply your polyurethane rubber, it'll come off fine. If your model is porous, so if it's wood, plaster, concrete, stone, you have to seal it first and then apply the release. Okay? A couple things about the polyurethane rubbers. Every rubber has a specific density. Okay? And when you're comparing different rubbers, and especially trying to figure out which is the least expensive rubber to use, you want to keep the density in mind. Okay? So here we have 2 different rubbers. This happens to be 7240, and this is 7430. These 2 pieces of rubber actually weigh the same. Right? So if I tell you this is a lot less expensive per pound than this rubber. So someone says, I want the cheapest rubber you have. They say, I see that 7240 is only, let's say, $3 a pound. And that 7430 that you keep recommending is $4 a pound. You guys are making a lot of money on that 7430. Well, a pound of 7240 and a pound of 7430 give you a lot different volume. Okay? So here we have 2 identical pieces of rubber. This one is about almost 50% heavier. So when you compare the cost of rubber, you want to compare the cost per cubic inch, because that's the real cost of your rubber. How many cubic inches does it take to fill that mold? It may take 10 pounds of this, it's going to take 15 pounds of this, and when you compare the cost of that mold this actually ends up being less expensive to use, even though it costs more per pound. So just keep in mind the densities of different rubbers when you're comparing apples to apples. The 74 series ranges from a very soft Shore Amp 20, this is 7420, very, very soft, up to the 81 series. We actually have, this is 8190, so this is getting very, very firm. This is starting to border on being plastic. And then we have 81D45. The D45 means it's over 100 on the A scale. We actually move on to the D scale, which is the scale we measure plastics on. So this is very, very hard. It's going to have virtually no flex to it. And we have hardnesses every 5 short points in between. All of these 74, 75, 77 series are all pourable products. So you mix A and B together, pour them over an object, they'll self-level. Some are thicker than others, but they'll all self-level and cure, and it doesn't matter the thickness. It could be a 1/4 inch, it could be a foot thick, it's going to cure at the same rate. All of these products can be thickened with a product called polyfiber. Polyfiber is a shredded polyethylene fiber. It can be mixed into liquid rubbers and make them brushable. So you can keep one rubber in your shop. You can take 7430 and pour it sometimes, thicken it with the polyfiber, and brush it on other times. So that polyfiber makes these pourable products pretty versatile as far as your mold making. When you're using these molds, and you have a finished polyurethane mold, if you're casting things like waxes and plaster, you really don't have to worry about release changes. Those materials will not stick to the rubber. If you're casting concrete, sometimes it sticks, sometimes it doesn't, and that depends on the rubber you're using and your concrete mix design. If you're casting things like polyurethane resins, epoxy resins, or polyester resins, then you need to apply release agent to the mold each time, otherwise those liquid plastics will bond to the rubber.
Back to the density thing, other than, well, why else is density important other than trying to calculate the cost of the rubber?
Well, that's the main reason. Density is important for calculating cost, but it's also important for figuring out how much material you need to make a mold.
Okay. Nothing to do with air bubbles or detailing.
You know, all of these polyurethane rubbers, no matter what the hardness is, will capture the same amount of detail. The only time you lose detail is if you have an air bubble against the model surface. Now you have a bubble in your mold, that's where you lose detail. Right? So generally, the lower viscosity material you use. So viscosity is how thick or thin a liquid is. Low viscosity is more fluid, more porable. High viscosity is thicker, less fluid. So 7420 happens to be our lowest viscosity rubber, about 800 centipoise, which is maybe like a thick milk as far as viscosity goes. Then you get into something like 7580. 7580 is about 3,000 centipoise or 3,500 centipoise. So that's kind of like a room temperature honey. Both still flow and both will capture the same detail. But this being thicker, if you've got super fine detail, you could trap air bubbles against your model with a thick liquid. I think that pretty much covers our polyurethane rubbers. You have questions?